Lesson 11-3, angle relationships and parallel lines. And in this lesson, you learn to identify the relationships of vertical, adjacent, complementary, supplementary angles, and angles formed by parallel lines and a transversal. Okay, why is it important? Because when you study the Earth's rotation and revolution, you will use angles. So let's take a look at this little bit of a hands-on activity. Take out a piece of paper for this, take out a straight edge, and take out your protractor. So notice that the writing lines on notebook paper are parallel lines, and if you recall, parallel lines are lines that do not intersect. You can use these lines to investigate angles in parallel lines. So let's do this. In your notebook, use lines on notebook paper to draw two parallel lines, and these are your two parallel lines. Then draw another line that intersect the two parallel lines, this line right here, okay? And use a protractor to measure all the angles formed when this line crosses the parallel lines. Make a sketch that includes a measure of each angle, and repeat this activity using a different line, okay? So let's just use this one. We'll not go to the last one. We'll just use this because it will be true for every single line that we do. But before we do that, let me just extend all these lines, okay? Because if you have longer lines, you will it'll be a lot easier to measure with your protractor. Okay, so this is my protractor, and I'm going to measure the angles. Okay, I'm going to measure that. Let me make this smaller first. Okay, so if I make this smaller right here, and I want to measure this particular angle right there, and I read it, okay, oops, that angle is approximately uh, 10 110 degrees. So this is around 110 degrees right here. Let me take out my protractor. So this is around 110 degrees. Okay, and if I measure this angle right here, this angle I want to measure, that rounds 70 degrees. So this angle is 70 degrees. Let me take that out. And this is 70 degrees right here. Okay, getting my protractor again. I'm going to measure this angle right here. And that is also 110 degrees. So this is also 110 degrees. Okay, getting the same protractor. This opening right here is 70 degrees. So this is also 70 degrees. Okay, and if I turn my protractor around so that I can now measure the bottom angles. Okay, and if I measure this angle right here, there is 110 degrees right there. So this is also 110 degrees. Okay, let's make that line smaller so it'll fit. So this is 110 degrees as well. And if I measure this angle, one last angle, then I'm going to stop. This is also, look at this, that angle is 70 degrees. And you can see the pattern right there. So this is 70 degrees right here. That angle right there. Okay, and you'll find out also that this is also 70 degrees. And this is also 110 degrees. And if you notice, there are only two values for the measures of all 8 angles. It's either 110 or 70 degrees, and it holds true for every single line that you create. Okay, let's say you want to draw another line. Oopsie. Okay, let me make this straight again. Never mind. Okay, I'm just going to take that thing out. So basically what happens is that if you draw another line that crosses those two parallel lines, you'll end up with the same, there will end up with only two values for 8 angles. Okay, of course they won't be 110 and 70, but they would total the sum of 180 degrees. Okay, so knowing what we did there in the activity, okay, let's learn the concept. So in the activity above, you discovered some of the special relationship that pairs of angles have. Okay, so let's start with definitions. When two angles intersect, they form two pairs of opposite angles called vertical angles. So in the figure at the left, which is this one, okay, angles 1 and 3 are vertical angles because they're opposite each other. Angles 2 and 4 are also vertical angles. And when you talk about vertical angles, if you use a protractor to measure the angles, you'll discover that the angles in each pair have the same measure. So therefore, angles with the same measure are congruent. Again, the word congruent means same measure. So vertical angles are always congruent. So angle 1 and 3 are congruent angles. Angles 2 and 4 are congruent angles. Another definition, when two angles in a plane have the same vertex and share a common side, and they do not overlap, they are called adjacent angles. And think of the word adjacent as next to, because this will be very important, that the word adjacent in the future lessons. Okay, so when they share a common side, in this case, look at this, they share a common side, that this side right there. Okay, the angle 1 and angle 2 are adjacent angles. So in the figure, angle 1 and angle 2 are called adjacent angles because they share a common side, and these angles are next to each other. Okay, so we can find the measure of angle AOB right here by adding the measures of angle 1 and angle 2. So if we add angle 1 and angle 2, you'll find the measure of angle AOB. So the measure of angle AOB is equal to the measure of angle 1 plus the measure of angle 2. We need to remember also that the measure of angle AOB means the degree measure of angle AOB. So we want to find the degrees, okay, the number in degrees. Okay, more definitions to come. So let's move on. If the sum of the measures of two angles is 90 degrees, or the angles are said to be complementary. And this is an example of a complementary angle. That box indicates a right angle. So angle 1 and angle 2 are complementary angle, meaning the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And we can also have angles that are not adjacent to each other, which are angles 3 and 4. Okay, so since the measure of angle 3 plus the measure of angle 4 will equal 90 degrees, these two angles are complementary angles. Okay, next definition. If the sum of the measure of two angles is 180, they are called supplementary angles. Okay, and this is an example of supplementary angles. Remember, this is a straight angle, an angle that creates a 180 degree angle. So if you get the measure of angle 1 plus the measure of angle 2, the sum will be 180 degrees. And these are for adjacent angles. For non-adjacent angles, angles 3 and 4, if you measure them, the measure of angle 3 plus the measure of angle 4 will also equal 180 degrees. Okay, which brings us to example number 1. Example number 1, use angles A, B, and C to solve each problem. So in this case, angle 1, angle A and B are complementary. So if that means they're complementary, the sum of these two angles are 90 degrees. So if the measure of angle A is 70 degrees, find the measure of angle B. We know for a fact that they're complementary. The measure of angle A plus the measure of angle B is equal to 90 degrees. Definition of complementary angles. We substitute the measure of angle A to be 70 degrees plus the measure of angle B, which is 90 degrees, and to be able to isolate the measure of angle B, we subtract 70 to both sides, so we end up with 20 degrees. Okay, so the measure of angle B is 20 degrees. Okay, so let's take a look at letter B. Angles A and C are supplementary. We want to find the measure of angle C. Okay, so we know for a fact that they're supplementary, that the measure of angle A plus the measure of angle C is equal to 180 degrees, definition of supplementary angles. And then we simply substitute the value. Okay, now we know. And we know that the measure of angle A is 70 degrees. We don't know the measure of angle C. Okay, so we simply subtract 70 to both sides. We end up with the measure of angle C at 110 degrees. Okay, so let's go on to example number 2, and we will connect this to algebra. Geometric relationships can be expressed using tools of algebra. Okay, so pay attention here because this can be confusing if you don't get this. So pause, rewind. Okay, pause, rewind if you don't get it the first time. So angles PQR and angle RQT are complementary. We know the word complementary means that their sum will be 90 degrees. So if the measure of angle PQR is x plus 5 and the measure of angle RQT is x minus 9, we want to find the measure of each angle. So this is how it looks like. Angle PQR is x plus 5 degrees. Angle of RQT is x minus 9 degrees. And we know for a fact that if you add those two angles, they should equal 90 degrees. Substitute the value for the measure of angle PQR and substitute the value for the measure of angle RQT. The measure of angle PQR is x plus 5. The measure of angle RQT is x minus 9. We add those two to get 90 degrees. And let's simplify the left side of our equation. X plus x will give you 2x. 5 minus 9 will give you negative 4. So it's going to be 2x minus 4 equals 90. We simply combined like terms. And this is a simple two-step equation. We add 4 to both sides. We end up with 2x equals 94. And we divide 2 to both sides of the equation, which is 47. So after getting the value of x, we simply replace x with 47 in the expression for each angle. So we get 47, and we plug that 47 to that angle, plug that 47 to that angle. So 47 plus 5, okay, will give you 52, and 47 minus 9 will give you 38. So the measure of the two angles is 38 degrees and 52 degrees. And it's easy to check this because they're complementary. So the sum of 52 plus 38 should equal 90 degrees. And it is. So these angles are complementary angles. Okay? And the final concept in this lesson, okay? Well, let's take a look at this. Think about it. Why is 47 not the measure of one angle? Okay? Because 47 is the value of x. And remember this. X is 47, but that is not the measure of one angle. It is simply the value of x. Okay? So that's one thing to think about. Final concept would be this one. Okay, remember at the beginning of the lesson we drew those lines. Okay, we have two parallel lines and we have line crossing those two parallel lines. As you discovered the modeling activity at the beginning of the lesson, when two parallel lines are intersect by a third line, this line now is called a transversal. So line T is a transversal because you have two parallel lines being intersected by this line. There are 8 angles that are formed. 4 are interior angles and 4 are exterior angles. What does that mean? 4 are interior angles. These are your interior angles because they are inside the parallel lines. Okay, those are interior angles. And 4 are exterior angles because they are outside of the parallel lines. Right here are exterior angles. Okay, so your interior angles are angles 3, 4, 5, and 6. Exterior angles are angles 1, 2, 7, and 8. Okay, so when we study the relationship between the different angles, we can pair the angles as follows. But before we do that, remember at the beginning of the lesson, okay, when we started measuring the angles, there were only two values that came up. Those two values always equaled 180 degrees. So even though there are 8 angles here, okay, there are only 2 values, okay, that we will come up with, which those 2 angle values will equal 180 degrees. So remember that as we go through some of the definitions. And think about it, why do you think these angles are referred to as interior and exterior angle? Well, I just told you that because they're inside. Interior means inside the parallel lines. Exterior means they're outside the parallel lines. Okay? So the first definition that we're going to talk about when you talk about transversal and parallel lines are alternate interior angles. So when you talk about alternate interior angles, remember these are only, if you talk about interior angles, there are only 3, 4, 5, and 6. Why are they alternate interior? Okay, because angle 3, or sorry, angle 4 and angle 6 alternate in terms of the sides, and that's why they're called alternate interior angles. Okay, and angle 3 and angle 5 are alternate interior angles as well. And when we talk about alternate interior angles are always, okay, congruent. So they are non-adjacent interior angles found on the opposite sides of the transversal. They alternate in terms of sides and they're non-adjacent. So they're always congruent. That means angle 4 and angle 6 are congruent. Angle 3 and angle 5 are congruent because they're alternate interior angles. So if you have alternate interior angles, we also have alternate exterior angles. Okay, so in this case, angles 1 and angle 7 are alternate exterior angles. Angles 2 and angle 8 are alternate exterior angles as well. And just like alternate interior angles, alternate exterior angles also are congruent. Okay? And finally, the last definition, okay? The secret word for this lesson would be all stars. The secret word would be all stars. Okay? So, the last definition would be corresponding angles. Corresponding angles are basically when you see the word correspond in math. Correspond means same location. So let's say in this line and that line right here, okay, we have angle 5. And if we take that line, we take the same transversal and angle L, where can you find angle 5 in when line L intersects line T? That would be 1. So line 5 will be in the same location as, angle 5 will be in the same location as angle 1, and they are corresponding angles. Okay, so angle 1 and angle 5, angle 2 and angle 6 are corresponding angles. Angles 3 and angle 7, angle 8 and angle 4 are also corresponding angles. Okay, the angles that have the same position or location, just like talk about, on 2 different parallel lines cut by a transversal. So when you talk about corresponding angles are also congruent. And let me refresh what congruent symbol means. 2 equal signs and a squiggly line. That means when you talk about alternate interior, alternate exterior, and corresponding angles, they are all congruent. Okay? So, parallel lines cut by a transversal, we have corresponding angles, alternate interior angles, and alternate exterior angles are congruent to each other. So let's apply what we know in example 3. A transversal crosses 2 parallel lines so that the measure of angle 4 is equal to 75 degrees. Okay, remember we talked about this. The measure of angle 4, this is angle 4, is 75 degrees. Okay, that means there will only be one measure, okay, which is supplementary to angle 4. Okay, there will be only 2 angle measures, okay, that you will find in all of these 8 angles. Okay, So let's take a look at this example. So if the measure of angle 4 is 75 degrees, which other angles also have the measure of 75 degrees? And let's take a look at this one. Okay. So we know for a fact that angle 4, okay, corresponds with angle 8. So this is also 75 degrees. Angle 4 is also an alternate interior angle of angle 6. So this is also 75 degrees. And let's take a look at this another way. Angle 2 and angle 4 are vertical angles. So this is also 75 degrees. We can also look at this way, that angle 2 and angle 1 are supplementary angles. That means, okay, this will be, angle 1 will be 105 degrees because they need to total 180. And since angle 1 and angle 3 are also vertical angles, this is also 105 degrees, and everything else follows. Angle 3 and angle 5, we can reason that they're also alternate interior, so that's also 105. Or angle 5 and 6 are also supplementary. And if you notice, angle 7, angle 8, and angle 5 are also supplementary. That's why it's 105 degrees. And lastly, angle 7 is and angle 8 are vertical angles. That's also 105 degrees. And angle 7 and angle 2, angle 1 and angle 7 are alternate exterior angles. That's why it's also 105 degrees. Now we named all the degrees. All we need to do is answer the questions. Find the measures of the other angles. Okay, which other angles also have a measure of 75 degrees? Angle 2, angle 4. Okay, so they also have it. Since angle 4 and angle 6 are alternate interior angles, okay, they also have 75 degrees. So our 75 degree angles are 2 and 4, 6 and 8. Okay, so find the other measures. We did that, and we defined how they got their measure. There are a few different ways to find those angles. So your angles 1, 3, 5, and 7 have measures of 105 degrees. Okay, and let's take a look at the last example. In construction, carpenter uses a protractor and a plumb line. This is a plumb line right here. Okay, a string with a weight attached to it. Okay, to measure the angle between a slanted ceiling and the wall. So this is your slanted ceiling and this is your plumb line. Okay, if the measure of angle WXY, where's WXY right here, is 65 degrees, you want to find the measure of X, Y, Z. Okay, so if this is 65 degrees, right here, we want to find the measure of X, Y, Z. Okay, now if you notice, right here, if I create a line, I extend my line, let me extend it, put it in red. So if you notice, if I extend that line right there, and this line right here, I will have two parallel lines cut by a transversal. So if we do that, okay, and this is 65 degrees, we know that this is also 65 degrees, and this is 115 degrees, because 115 and 65 will give you 180 degrees, and it's just asking for the measure of angle X, Y, Z, which is this angle right here. Okay, so if that's 65, that's 115, we can now reason that this angle right here is the alternate interior angle of this angle right here, XYZ. So this is also 115 degrees. And that's how we get it. Okay, 180 degrees right there. And then we get 115, and that's exactly what we get. Okay, and these are just making it longer, but using two parallel lines, This segment B creates a transversal, and we simply apply what we learned in the previous example. Okay? And that's our lesson. Thank you for watching.